The second thing we did, or the first thing we did, was figure out what a scatter plot was. Can anyone tell me what the difference between both of them are? Who knows the difference? Okay, Kareem.
So basically, a linear relation, it's like a line, it's like a line, straight line.
Yep.
Either goes positive or negative, or correlation.
Okay, that's fine.
Correlation.
Okay.
So
Does it pass through all the lines or just some?
No, it doesn't pass through all the lines. No, it passes through all the lines.
Yeah, so a linear relation passes through all the lines.
A scatter plot.
Okay.
A scatter plot.
Can I draw my example?
So, pardon?
I'm going to draw the example of a linear relation, sir. So a linear relation passes through all points.
And then a scatter plot.
Okay.
It's like I don't know how to just like show it to you.
It's in the word itself.
Oh, okay. So like points that are scattered.
There we go. Thank you.
You just have to like connect them together.
You don't connect them together. You don't connect the dots.
No,
It's not a fun game.
Okay.
A line of what fit? What is it called?
Oh, a line. Okay. I know this.
Okay.
Last lesson, basically a line that goes through all, close to like all the dots, you know.
Good job.
Good job.
That's what it's like. I totally do that.
Okay, so this is called a line of best fit. So it's basically just a line that passes through most of the points or as close as possible to all of them, or lob. There we go. You're going to say lob. That's what it's called. Line of best fit. So we also learned about yesterday what part is the x-axis and which is my y-axis. So does anyone want to tell me which one's my x and which one's my y? Sean?
Your x-axis is the bottom line and your y-axis is the top.
Perfect.
Y to the sky.
Y to the sky. So which one has to do with my independent variable and which one has to do with my dependent variable? Let's see. Sean?
I think your independent variable
Is
the x.
Yep.
And your dependent variable is y.
Perfect. And my y is my dependent. Perfect. So if I have something like time versus distance traveled, which one do you think is going to be my independent and which one's my dependent variable? Does my time depend on my travel, or does my time depend on my distance, or does my distance depend on how much I traveled or how much time I spent on the road?
Isn't it the time?
Nope.
Oh, the opposite. Oh,
Yeah.
The time is your independent
Yep.
variable and the distance.
Because think about it this way. If I'm going on a trip, my distance or how far I drive depends on how long I'm actually on the road for. Okay, let's go with another one. So hashtag item sold versus my profit or money made, which is what this is called. So which one would be my independent? Which one's my dependent in this case? Does my profit depend on the number of items I sell, or does the number of items I sell depend on how much I make? Maya?
The amount of items sold affects the profit.
Okay, so which one's dependent? Which one's independent?
So the independent items.
Opposite.
Okay.
Yep.
So the independent is the profit.
Oh, did you say independent was item sold first?
Yeah.
Oh, never mind. You're right. Oops. I thought I heard dependent. So yeah, so your dependent variable is your profit because that depends on how much items you sell. So if I sell 12 items, I make this much money. So are we all clear with that? We're good? All right. Now we'll get to the page where what you guys actually have in front of you. So if you missed this part, I'll come back to it so you can copy it. So what we're going to learn about today is something called the rate of change, which is rise over run. So yesterday, when we had my equation, let's say What was an equation we used yesterday? Y is equal to what?
4x plus 5.
Thank you. Okay, let's see if you guys remember what we talked about yesterday. What did I say my 5 was? Yep, the number that hits the y-axis, or your initial value.
I'll go to the washroom.
Yep. So this hits the y-axis. Okay. Now, the number in front of my variable, we used a different word yesterday because it was less complicated and easy to remember. What did the number in front of the variable represent yesterday? Look at your notes if you can't remember. What was the word I used, John? The pattern. So in this case, what would my pattern be? Caitlin. Yeah, so I increased by 4. So, and then I was able, we were able to come up with our table of values. Remember, I started with 0, 1, 2, 3. So what was my initial value here? It's 5. And then after that, I just go with the pattern. So what comes next? What comes after 5? If we're increasing by 4. Austin.
9,
9. Then?
14.
Okay. And what's the last one?
14.
Yep. There we go. Wait. 9 plus 4 is 13. Yep. We're off by a bit. That's fine. 17. Perfect. So, and then we said these combined together make our coordinates, which help us graph our line. So this coordinate is going to be 0, 5, 1, 9, 2, 13, and 3, 17. Okay. However, now that we're going to use this fancy schmancy language, what our linear equation, what we learned yesterday of like y is equal to 4x plus 5, the general formula for that is going to be known as y is equal to mx plus b, so which is right here. So I'm going to let you guys copy this down first, and then I'll continue with what y is equal to mx plus b is. So the rate of change, so when we talk about the rate of change, we're talking about that number that's in front of my variable. So for example, here, that 4 that's in front of the x, we called it our pattern. That's actually the rate of change. It's what happens throughout the graph is what changes. So in this case, each time my graph is increasing by 4. Oh, okay. So that pattern you see, which is 4, that is now known as your slope or rate of change. It's just a fancy way of saying pattern. That's it. So the rate of change is the slope of the line, so it's the steepness of the line. So remember yesterday how we had different numbers and each line was different in steepness. So what did I say? The bigger the number, is it more steep or less steep? More steep. And the lower the number, so if it's a very small fraction, the less steep your number is going to be. So the slope or the ratio of the change, so the slope is the ratio between the change of the dependent variable versus the independent variable. So this is where this whole rise over run comes from. So your rise is your y-axis, and your run has to do with your x-axis. So like I said, this is what we're going to learn about. Y is equal to mx plus b. So for example, if we have y is equal to 3x plus 4, your 3 is your slope or your rate of change, or like I said, another fancy way for saying the word pattern. And your 4 is your initial value. So this is where your graph touches the y-axis. I almost spelled initial wrong. So this is where the graph touches the x-axis, or y-axis, sorry. Okay. So we're going to be looking at rate of change here in terms of just looking at points on the graph and seeing how far up and how far to the left or to the right we have to move our, I guess, we have to move to get to that specific point. Okay, I'll wait for you guys to finish copying what I just wrote. Okay, so now we're going to talk about that rate of change, which is rise over 1. So basically, what I'm going to start with my rise is my y's, is how far up do I have to go or down do I have to go, and my run is how much to the right I'm going. So my rise is going to be up or down, and my run is always going to be to the right. Okay, so if you have a negative number, it's always going to be your rise, because you're either going up or down. If you're going up, it's a positive. If you're going down, it's what? Negative. Yeah. So the first one here we have is 2 sets of points. So we have this perfect point over here, and we have this perfect point up here. So can someone tell me what the coordinates are for this first red line, or red dot, sorry. Maya? 1 and 1. And what's the point for my second red dot? Matthew?
4, 5.
4, 5. Good. So I need to figure out my rise over my run. So my rise has to do with my y values, okay? So the y value of the first one is 1, and the y value of my second guy is 5, which means I have to go 1, 2, 3, 4 units up to get to 5. So that's my rise. So my first x value is 1, and my second x value is 4. So how much to the right do I have to go to get to 4? Right? 3. 1, 2, 3. So what's the slope of my line then? 4 over 3. So it's easy as it gets. Yeah. So when we read graphs, we read them from left to right. Okay, so our answer makes sense here because from left to right, my line is going up. If you got a negative answer, then you probably messed it up. Okay. So let's start with our next one. So what do you think my slope is going to be? Is it going to be positive or negative?
Negative.
Negative. Okay, so again, pick perfect points. So here and here. So remember, we read from left to right. So what's my first point? Matthew?
Negative 5 and 1.
Nope.
5 and 1.
Nope. X first, then Y. Sean?
1.
There's no negatives.
Look, X is the bottom.
There's no negatives here. I'm talking, I just want you to tell me the coordinates. I'm not doing this.
5.
Not the first one. Maya, what's the first one?
2, 5.
2, 5. Okay, what's my second one? Matthew,
5, 5.
not 5, 5. So it's 5. My x value is 5, but what's my y value? 1. 5 and 1. So again, we're going to have to do the same thing. Slope is equal to rise over run. So you remember we're going from left to right. So my first y value here is 5. And my second y value is 1. So am I increasing or decreasing if I'm going from 5 to 1? Decreasing. So I'm going 1, 2, 3, 4 units down. So what would my rise be in terms of a number? Positive or negative? Negative what? Negative what?
3.
No, we just said it. Negative 4. Okay. My first x value is 2, and my second x value is 5. So from 2 to 5, how much am I going to the right? Kareem.
Is it 1?
Nope.
Wait, sorry.
Claire? 3. All you're doing is making a triangle with the points.
But I thought you started from the bottom, right?
No, you don't. What did I say we read graphs as? From right to left or left to right? So am I reading graphs from left to right or right to left? Yeah. So is my first point the highest point or the lowest point? Yeah, my first point is up here. Okay. And then this is my second point. So I'm going to try another one with all of you. I'm going to draw it here. So let me pick, let's see. Okay, let me draw that line. Oh, that's a terrible straight line. Holy smokes. Okay, so I want you to tell me what the slope is for that black line I just made. The slope of the black line. Try to figure that one out. Sean?
Like the y-axis is 2 and 5.
No, I'm talking about this line right here.
What happened?
I'm not.
I made this black line right here. What is my slope? Maya?
Negative 4 over 1.
Which is the same thing as? What's negative 4 divided by 1? Yeah. So as you can see, I'm going to go down 1, 2, 3, 4, which is negative 4, which is my rise, and I'm going to move 1 to the right. So I got negative 4 over 1.
Are we supposed to write like the top and the bottom
Yep.
part? Like,
What's your corner for the top, Sean?
would it be negative?
There's no.
No, sorry, 1 and 5.
Not 1 and 5. What's over here? Here at the bottom.
0.
Yeah, so it's going to be 0, 5. That's the first point.
Why would it be 0? Like the dot?
Because my dot lies on the y-axis, and whenever I have something on the y-axis, my x value is always 0.
Oh, okay.
So what's my next point at the bottom? Kareem?
Is that a
No, it's not a 2.
no? I can't. One over 2. You said the point at that point.
Yeah, I'm talking about this point. It's not 1 and 2. Gian? 1, 1.
I didn't. That's what I didn't see.
That's okay. So, in other words, my first y value is 5, and my second y value is 1. So to get from 5 to 1, I have to subtract by 4. And then my first x value is 0 and my second x value is 1. So to get from 0 to 1, I just add 1, which is why I have negative 4 over 1 as my slope, which is the same thing as just negative 4. Good-ish? Okay. We have 2 more. Oh, so for the next one, I want you guys to figure out the slope of each line. So we'll do the first one together. So I have my first point up top over here, and my second point isn't perfect until that guy right there. So I'm gonna put the scale for you just so you can see. So what's the first coordinate for my top point? What's the first coordinate? Kareem?
Negative 1 and 2.
Yeah, negative 1, 2. Perfect. And what's my second coordinate at the bottom? Adam?
3, negative 1.
3, negative 1. So now I want you guys to figure out your slope using rise over run. And then let's see what you get. Anyone want to give the answer? Maya?
Negative 3, 4.
Perfect. Negative 3 over 4. Perfect. So we're going to go 3 units down. 1, 2, 3. And then 4 to the right. 1, 2, 3, 4. Everyone else get negative 3 over 4? Good? All you're doing is making a triangle, basically. That's it. Okay, the next one. Let's see if you guys can do this on your own. So where's my first point going to be? Not the top. Remember, from left to right? The bottom? And what's my second point going to be? Are you sure?
Yeah.
Is there another point in between the top and the bottom?
No.
Are you sure?
There's a point in the line.
In the middle.
Wait, you have to count that?
Oh,
Yeah.
are you talking about where the line is? Oh.
It doesn't necessarily have to be the first and the last point. There could be points in between that are perfect. So again, I'm going to do the scale. I'm at 575% zoom. Wow. Okay. So what's my first point at the bottom? What would it be? My first coordinate. Kareem.
Negative 3 and 1.
Yep. Someone else tell me the second coordinate. Sienna. Negative 1, 2. So now I want you guys to find your slope as rise over run. Let's see what you guys can come up with as your slope. Gian, what's the slope? 1 over 2. So my rise is 1, so I go up 1. Let's do purple. I go up 1, and then I go 2 to the right. Yeah. Any questions? Yes, Austin?
Can you tell me how it works on rollers?
Okay. So my first y value, so we're going to focus on my rise. My first y value is 1, and my second y value is 2. So how do I get from 1 to 2? What do I have to add? 1, right? My first x value is -3. My second x value is -2. So to get from -3 to -1, what do I have to add? Yeah. So 2 to the right, which is why you get a rise of 1 and a run of 2, which is why your slope is 1 over 2.
So, does it really matter if we do one at the very top? Because either way, we're technically simplifying.
Yeah, you'll get 2 over 4, so you'll simplify it to 1/2. So there. Okay, let's do another one. I'm going to put some random points here. Okay, so let's do this. Okay, so I want you guys to find the slope of this red line I just made. So take a couple minutes to figure the slope of that red line. So my first point, so Joey said 6 over 3, which is right. So my first point is 2 and -1. And my second point is 5 and 5.
But isn't there another? There's
Yeah, that's fine, but we'll do it this way right now. You can do it either way, it doesn't matter. Because you have to simplify at the end anyways. I would take whatever, as long as you simplify it at the end. If you left it at 6 over 3, I would be like, no, you can simplify it.
So there's an option to count the ones in the middle.
Yep.
So you don't have to do it.
So my first y value is -1, and my second y value is 5. So to get from -1 to 5, I have to basically add 6 or go 6 units up. 1, 2, 3, 4, 5, 6. So my rise over here is going to be 6. Now my run, my first x value is 2. My second x value is 5. So to get from 2 to 5, I have to add 3, which means I'm going 3 spaces to the right. So what does my slope simplify into? 6 over 3 is the same thing as what? Sean?
2 over 1.
2 over 1 or just 2? So my slope is going to be 2. Yeah.
Do we have to have the extra numbers if we can just get away with so if I just count the boxes from the bottom
Mhm.
to the top one?
That's fine. I was just showing another way to do it.
Okay.
You don't have to. If I ask you to tell me the coordinates, then you have to tell me the coordinates. So it's pretty easy. Yeah, this writing's actually pretty small now that I go into normal zoom. It's terrible. All right. So now the next one, we have a horizontal line. Yes.
But the first coordinate is negative, you wouldn't have to add that.
What do you mean?
Like it's 2 and negative 1.
Yep.
So you, even though it's 3, you don't have to write negative 3. It's just 3.
So remember, it's 3 because I'm moving 3 to the right once I hit the top.
But it doesn't matter if it's negative. It's just
It's
how
3.
many.
Yep. How many spaces? Okay, so now we have a horizontal line. So just by looking at it, do I have a rise with a horizontal line? So what's my rise? 0. And what's my run?
No, not 0. 'Cause-
What would my run be?
Oh. It'd be
We'll say 7. Okay, so from here to here, that would be 7 spaces. So what's 0 divided by 7? 0. So my slope is going to be 0. So every time you see a horizontal line, my slope is going to be 0. So 1, 2, 3, 4, 5, 6, 7. Okay, now we have something called a vertical line. So my vertical line, again, m is equal to rise over run. What is my rise for this vertical line? So for these specific points, what's my rise? Adam, we'll say 6. What's my run? 0. So when you guys take your handy dandy calculators and do 6 divided by 0, what do you get?
0. Oh no, wait, 6.
Nope. Doesn't exist. I like saying D and E. I don't like saying undefined. My slope does not exist. Okay? Because I cannot divide anything by 0. I haven't done my exclamation point smiley face. So we're good.
is it more?
Well, since it doesn't exist.
Okay. So now we're going to do a second one. So we have a line segment that has 1 point at -3 and 2 and a slope of -4 over 5. I want to find the next coordinate. I want to find the other coordinate. So I'm going to draw my scales. So -1, -2, because it is. I'm gonna 1, 2, 3, 4, 5, 6, 7. -1, -2, -3. So can someone tell me or point to me where that coordinate -3 over 2, -3 and 2 is going to be drawn? I don't know if someone wants to come up and point it at the board. Okay, Kareem, point at the board. Where is -3 and 2 going to be drawn? Yep, there we go. Perfect. Thank you, sir. You can go. No, you can go sit down. Yeah, I'm good. So that's my point -3 and 2. So I know my slope is -4 over 5. So how am I going to use that point -3 and 2 to determine my other points? So what's my rise? Maya? Okay, what's my run? Does anyone want to come up and tell me where the other point is going to be? No, Sean? You sure?
Yeah.
I volunteer Sean.
No.
Yeah.
I don't know
Okay,
where
Maya.
to go.
It's okay. No, don't force them.
Just get Maya.
What is the top one again?
-4. So I'm going 4 units down, and how much to the right? So 2 and -2. So I'm going 4 units down, and then 5 to the right, which takes me to the point 2 and -2. Yeah. So technically, you can sketch your line. So my line's going to go like this. Well, that's a terrible line. Again, Jesus. Okay, that's as straight as it's going to get. Okay, don't judge my crooked lines. So that's my line segment.
I had a teacher that used to do that to the curve. That's weird. Then at one point I have to
So with this, we learned the formula y is equal to mx plus b, right? So what did I say my m was? Sienna? My slope. So what's my slope in this case? Yep. So this is y is equal to -4 over 5x plus b. Okay. So let's try to use our algebra to try to figure out what my b value is, where my graph will cross the y-axis. Is there any point that we can use in the question to help us figure out what b is? Does my coordinate contain an x and y value? Yes. So my point -3 and 2 contains x and y. So -3 is x and 2 is y. So how can we use those numbers to help us figure out what b is? Maya?
You take the y.
Mm-hmm. Yep. And then you plug in -3 for x. Oh, look, guys, look, it's algebra again. It's equations. So who can tell me what -4 over 5 times -3 gives me? What's -4 over 5 times -3? Alice? Yep, 12 over 5 plus b. Remember, I want the variable b to be alone. So is there anything I have to move over?
Oh, we're going back to the.
Austin.
Is it the 12 over 5?
Yeah, we're gonna move it over, so it becomes what?
Maybe
Yep.
12 over 5?
Perfect. Oh, look, we have common denominators now. Wow, fractions. Oh my gosh. So, yeah, it's back to square one. So, do I have the same denominators on my left side? Nope. Kareem, what's my lowest common denominator?
What? Oh,
Laura?
I was gonna answer
5.
that.
It's 5. Which means I have to multiply my second fraction by 5. Thank you. So I get 10 over 5 minus 12 over 5 is equal to b, which means b is equal to -2 over 5. So now my whole equation is y is equal to -4 over 5x minus 2 over 5. Look at that. We just took like 3 units and combined them all into one thing.
Why not?
It's okay. I think we have one more example. Yeah. So let's do the first one together. So I want to find the linear relation in y is equal to mx plus b for each of the following graphs. So in some cases, you're able to find your b value just looking at the graph. So in this case, what is my b value? At what value does my graph cross the y-axis? Where does it hit it?
Can you repeat the question?
So where does my graph hit the y-axis? At what number? Sienna?
5. Is that 0?
5. So my b is going to be 5 because that's where my graph crosses the y-axis. Now, can someone tell me what my slope is as rise over run? And oh, look, I gave you some points to work with too. So figure out my slope and then tell me what my slope is. Gian. -2. So I'm going to go 2 down. So my rise is -2 and my run is 1 to the right, which means my slope is going to be -2. So now I can write my equation as y is equal to mx plus b. So can someone tell me what my m is? We figured it out. What's my m? It's up on the board. -2. What's my b? 5. So my equation is y is equal to -2x plus 5. So remember, the b is the easiest one because you're able to tell usually when it hits the y-axis. So in this case, my graph hits the y-axis at a y value of 5. So you guys are going to do 2 and 3, and then 4 is the more difficult one. So to do 2 and 3 on your own, I'll come and check it out, and then do 4 after that.